Hi guys, I'm going to talk about my second project idea for Mark's class. Um, if you can't tell, I am a chemistry teacher. I don't just have a periodic table up in my house for fun. I've been teaching, from my basement for basically since March, so almost a year now. Oregon is still closed down. We're talking about opening up here in the next couple months. I think grade schools first, and then hopefully high school. But in the meantime, I've been, busy having fun learning how to stream through OBS and run my Zoom classes, right, for my students and trying to keep them interested as much as possible. But I got really excited when I found out that this was going to be an art project, and I've been wanting to do this for quite a while. It combines a lot of things that I'm interested in. So in addition to chemistry, I also help out with our school's robotics team. So we are St. Helens Robotics and Engineering Club, Shrek, Team 5450. You know, it's been tough. The students who participate, they're not really able to participate because we don't have a place to build since our school's closed and everything's kind of pared down this year. So I'm actually working on some Arduino projects with them and have done a lot of stuff with Arduino in my engineering classes and just basic interest, right? I kind of a geek. I like doing this stuff, which is why I think, all of us kind of gravitate towards Mark. We like watching his projects and especially all the builds. I really like all the microcontrollers that he uses. So one, I have a decent background with Arduino and electronics projects, and I wanted to tie in chemistry. And then we're getting a new school. We just passed a bond right before the pandemic, and so in the next couple of years, I'll be getting a new science classroom, and I want a nice art display to go on the wall. So here is my idea. Let me shift over. Um, what I found online a little simulation of electron density or electron probabilities based on solutions to the Schrodinger equation, right? That's pretty simple. And this simulation, I got to give credit to Peter Bird because I'm stealing all his equations, right? I just looked through all his JavaScript and found how he generated this plot. But my idea is not to just, generate a plot with just an Arduino, but I'm going to take um, this code that basically puts dots in space to represent the probable locations of electrons in the 1s orbital or the 2s or 3s orbitals, right? And this is kind of cool. It generates a histogram, and you can see how electrons have to tunnel through certain regions where they can't be found. So there's some cool quantum mechanics shown in here. Okay, and just to show you a little more, here's a p orbital, and the p orbitals kind of look like dumbbells and have lobes. And so my idea is I'm going to take this and I'm going to generate it using an Arduino. Okay, and to plot it, instead of plotting it on a computer screen, I'm going to be plotting it on glow in the dark burst. So I'm taking a page out of Mark's book. Okay, I got this inspiration from him. So I've got some glow in the dark vinyl coming, and I am going to shoot, okay, a laser at it. So let me turn off my lights so you guys can see. I've got my blue laser and I've got a violet laser coming. But my idea is I'm going to shoot probable locations of electron, right? And generate what's called an electron orbital, okay? Kind of a 2D representation of an electron orbital. And hopefully with the persistence of this glow-in-the-dark paper, you'll actually see it. That's my hope. I don't know if it's going to come out perfect, but if not, I'll at least have this cool screen that I can, play with and set up in my classroom and wow my students with. Okay, but how do you get the laser to hit the paper or the vinyl where you want it to? And so, I was actually thinking, okay, I know I could do mirrors and you could do this. I was planning on building it. And then I found out that, laser light show people have been doing this forever. So here is, let me go back. Oh yeah, and that's the cool p orbital. So if you can imagine, right, creating a set of lobes on a big 3 foot by 3 foot or 4 foot by 4 foot glow in the dark screen for my classroom. So like when my lights are off in my classroom, I'm hoping that this art display turns on, right? That could be one of the cool features, right? That Mark was talking about, put a light sensor in there and tell it. But let me show you this. So I found that laser light show enthusiasts, right, have been using what's called a galvanometer, which is basically a little how our electrical like needles work in old voltmeters. If you had a little analog voltmeter and you see the needle flipping back and forth, well, that's on a galvanometer. Okay, and a galvanometer is basically an electrical coil that'll cause something to rotate. So this has some mirrors on it, and I didn't make this. I bought this off Amazon. So after researching a little bit, I figured that this would fit the ticket and I purchased it. So here's the video. All right, so I've made some progress on my Mark Rober project number 2. So I've got a set of laser light show, they're galvanometers. I guess laser light show people call them galvos. And I bought these on Amazon. And what it is, there's two little electrical coils, one operating like kind of uh, in an X direction and then 90 degrees offset from that. There's one twisting in the Y direction. And they, in combination, right, controlled by this control unit, they'll create these cool patterns. So my idea, I'm going to replace this, and other people have done it, but replace this with a Arduino controlled set of digital to analog converters. And I'll run a little analog signal to these. And instead of plotting cool designs, I'm going to plot the probability density function, or like the solutions to the Schrodinger equation for the hydrogen orbital. All right, so hopefully you get that I'm gonna be basically be replacing the unit with an Arduino that I program with the same code from that website. So, generate some orbital representations, and I did go ahead and make sure that I could do this. So this was kind of my little prototyping or like proof of concept. So I went into Excel, right? Engineers love Excel. I'm an engineer by background before I was teaching. And I set up my little simulation. So I've got some constants up at the top. Again, these constants came from that website. I could have looked back in my physical chemistry book and made my professors really happy, but I just went the easy way and just viewed source on the web page. And I went through and I generated a bunch of points. Now, the way that the code works is it generates a series of points and then it filters out the ones that fall into the probability distribution function, or solutions to it. So it kind of filters them out. So these 10,000 points end up giving a X and a Y coordinate, and you can see a bunch of zeros here. Those are the filtered out ones. And then I just plotted the solution. So this is the 2s orbital. So I'm hoping that I got to figure out how to translate XY into rotation, right? So I have that little set of galvanometers and I'll have to rotate the mirrors. And those are based on a analog signal. And so I'll send an analog signal out and I'll pulse my laser and it'll create a dot, and then it'll quickly, because those galvanometers can run exceptionally like fast, it'll move to the next point, pulse the laser, create it, and hopefully with the persistence of the glow in the dark, you should see like that shape. And instead of being blue, right, it's going to be the green dots up on my screen. So other thing I did test, and I don't have it to show you guys, I hooked up a little MOSFET. So my laser pen uses a little bit more power than the Arduino pins are rated for. So I've got that running through a secondary kind of power supply, and I tested that. So I think if I can pull this together, it's doable. So I know it's doable. It's gonna be a challenge. I don't know if it's gonna be done in time, but the nice thing is the construction's starting this summer and probably won't be done for a year. So my new classroom, if I want to put this art display in it, I've got some time. So anyways, sorry for running long. Hopefully everybody else's projects are going well, and I really have enjoyed watching what you guys build. So anyways, I will talk to you guys later. Thanks.